Welcome to my Introduction to Networking course, also known as ITN. This is the version 7 material preparing learners for the Cisco CCNA 200-301. Cisco curriculum, everything is owned and copyrighted by them. Module 15, Application Layer. In this module, we're looking at the application functionality of the OSI. So we're looking at layers 7, 6, and 5, session, presentation, and application. We're going to end up with talking about some overall structures and services. So we're going to be talking about client server and peer-to-peer networking. We're going to talk about web and email protocols, some basic IP service functionality, DHCP and DNS, and we're going to end it with file sharing. So let's go ahead and jump right on in. Looking at layers 5, 6, and 7, they make up the application layer of the OSI. They also make up the single application layer of the TCP/IP model. The application layer provides basically the interface between the application that we use, the user uses, and the overall functionality of the additional layers, the lower layers, the data flow layers for that communication. OSI, when we're looking at the overall application layer, we're looking at protocols like HTTP, FTP, IMAP, and DNS. Those are all happening at the typical layer 7 portion of the OSI. Again, this is going to be what we, people, interact with. If we're looking at the presentation and session layers, again, these still make up the application layer of both the OSI and the TCP/IP models. The presentation and layer is dealing with the formatting and the presenting of the data at the source device, and it ensures it's in a compatible format. Essentially, this is what's going to be building out the extensions. Is it a .movie? Is it a .jpeg? Is it a .mpg or mpeg? That's what the presentation layer is going to be dealing with. It also deals with the compression data as well as encrypting data for transmission. It also will handle the decrypting of data upon it actually getting it. The session layer is created and maintains a dialogue between source and destination applications for that transmitting of data. It handles the exchange of information to initiate the dialogue, keep them active, and restart if necessary. So it's really important to understand that the presentation deals with formatting, compression, and encryption. The session layer is about being able to maintain the sessions between source and destination. TCP application, again, kind of puts all of them into one giant layer. So when we look at functionality, we have to look at certain things like DNS. DNS is what looks up our domain name services. It takes our domain names and responds them or actually looks them up to a correlating IP address and vice versa. Google.com will be translated to Google's IP address via DNS. The host configuration is going to be done through DHCP. That stands for Dynamic Host Configuration Protocol. This is what allows us to assign address information. If we're not manually assigning addresses, we have to do it dynamically, and that's done through DHCP. If we're looking at web resources, HTTP or HTTPS, HTTP will use port 80, HTTPS will use port 443. This is the set of rules for exchanging web content, web pages, things of that nature. So let's go ahead and let's talk about some server hierarchy models. Peer-to-peer is one of them. The first one we have to talk about is client-server, though. Client-server has a dedicated server, and you have multiple clients that will connect to that one server. Clients can be anything requesting resources that server serves. In contrast, we have a peer-to-peer network. In peer-to-peer networks, everything is both client and server. Each device will serve whatever resources they have. Each peer can also then request those resources as they're serving the resources that they have. Basically, peer-to-peer applications allow for devices to act as both, and so sometimes these are called hybrid systems. They can both send and receive. They can both be a server and request resources. Common peer-to-peer applications are torrents, for example. I can ask, who has this file? And I can reach out to all of my peers. The people that have those files would then respond. Not all torrents are illegal. Some game platforms, like WoW, World of Warcraft, will actually distribute updates via torrents. That way, they can use everyone in the community that plays World of Warcraft to distribute those updates. That way, not all of the load is on the WoW server for sending out those updates. Moving right along, we have our web and email protocols. These are going to be the protocols used for working on the web and sending emails. So when you go to a website like google.com, www is actually a subdomain, but we don't always see it. But there is actually a protocol or a scheme at the very beginning. HTTP or HTTPS is the protocol or scheme. Then the actual domain, the fully qualified domain name would be like www.cisco.com. www is the subdomain of Cisco. And then the .com actually is an extension. We are requesting a very specific file in this slide. You'll notice the index.html. That is the specific file being requested. So what ends up happening behind the scenes? HTTP or HTTPS will actually use a GET request to retrieve a website. The GET request actually will retrieve the file and then will display it on your web browser. Step 3 is typically the response of the request. The server will send the code for the website. Step 4, our web browser will display that code in our web browser. So HTTP and HTTPS has several common messaging types. 3, just for example, are GET, POST, and PUT. GET is what is used to retrieve web requests. POST, this is basically a upload data file to a web server, such as a data form. PUT basically is upload a web resource or content to the web server, such as an image. So if you're uploading an image, it's using PUT. If you're trying to upload specific types of data, it might use a POST request. If you're retrieving content, it's using a GET request. Again, these are just 3 of the more common types of messages in our HTTP and HTTP requests types. Moving on, let's talk about email protocols. So, we have 2 main types of email protocols, sending and receiving. And it's really funny because people forget that email is not just one-sided, it's both. So if we're looking at what protocol sends email, that's always going to be Simple Mail Transfer Protocol, SMTP. That is the main protocol used to send email. If we're talking receiving email, that actually is either going to be IMAP or POP. And actually more and more IMAP is taking over. And those are used, again, to receive email. So when you go to actually send an email, you will send SMTP using the SMTP ports and it will go to a mail server. The mail server will then actually have to forward it to the recipient's mail server for them to download it using one of their email services for receiving. Again, IMAP or POP. There are very specific names when we deal with this. Mail transfer agents, delivery agents are also going to be there. Okay, we're not going to talk about mail transfer agents quite yet. So, SMTP uses port 25 to send email. For the receiving of email, if you're using POP, POP is only used to go from the server, the recipient server, to the recipient, the delivery email. That is, in this example, using POP3. POP3 will use TCP port 110. The issue is POP3 is one of the protocols, but when you actually have email on multiple devices, POP will download the email to one device off the server. Well, the problem with that is that's not always the most effective way to deal with this. If you have a phone and a computer, well, only one device will get it. So POP3 has some very limitations in that regard. Basically, in this example, if we're dealing with POP3, the client actually has to pull the POP server, exchange the appropriate commands and responses, and then once they actually receive it, they will get them. Again, POP3, POP, doesn't store messages. It is not recommended for small businesses at all. The appropriate message would be IMAP. IMAP is going to be the main protocol. Here, I know it doesn't quite say mail delivery, mail transfer agent, or whatnot, but these are going to be things that you need to know for the exam. The sender will send an email using SMTP. That will be sent to an email server. That server is going to be also known as a mail transfer agent, MTA. The mail transfer agent will forward the email to the mail delivery agent. And that is going to be the recipient server. The recipient server is then going to deliver the email based off of whatever protocol you have. Again, in this example, we're going to talk about IMAP. IMAP actually keeps a copy of the message on the server. That way, if you have 2, 3, 5 devices, whatever, each device will actually sync between itself and the email server. Thus, if you get an email, it goes to all of the devices. If you read one email, that read receipt will go to the server. The server then will push it out to all the devices that have that same email address. So moving on, let's talk about, and that is this chapter in a nutshell. If you have any questions or concerns, please reach out.